Today we are working on section 7.3 called multivariable linear systems. The idea here is we are still working with linear systems, and again, a system is just one or more equations all together, where you're looking for one solution. And we're going to start with actually a form that we may or may not have heard of before. It's if a system is specifically written. Here we have 3 equations and 3 variables, and it's specifically written where there are no x and y terms in the bottom equation. There is no x term in the middle equation. The top has like at least an x and possibly some other pieces after it, but usually there's 3 terms there. That's called row echelon form, and the reason this is a helpful name or why this is an important form is because it's actually really easy to solve for our complete solution here, because the bottom equation has told us it is an absolute fact that z is equal to 2. Because we know this, we can actually substitute z equal to 2 into the equation right above it, and it would read y plus 3 times 2 equals 5. And again, this is going to be an easy equation to solve. Y now has to equal -1, so now I have 2 important pieces of information that I can take both pieces of information and substitute them into the top equation, and it would read x minus 2 times -1 plus 3. Remember, z is equal to 2, and I say equals 9, so this is going to be x plus 2 plus 6 equals 9, so I'm going to subtract 8 to both sides. X is going to equal 1, and now I have my final solution. 1, -1, 2 is the solution to this multivariable linear system. Now, this problem is one of the easier ones because it was already in row echelon form, and this process that we just used is called back substitution, because we essentially started at the end and substituted backwards in to get our information and eventually come up with our solution. Now, so obviously row echelon form made it pretty straightforward to solve that system. Our goal moving forward is going to be able to put systems into row echelon form, and we're going to do that by following 3 rules. And those 3 rules is you're going to have, let's say you have 3 variables and 3 equations. 3 things you can do. 1, you can switch those 2 equations so you can list them in any order you want. Whichever one you want on top, whichever one you want in the middle, and whichever one you want in the bottom. All right? Or you could multiply both sides of an equation by a non-zero number. We've done that since Algebra 1. All right? Now we're just doing it to a linear system. In fact, you did it when you were solving linear systems in the last section, 7.2. And the last one, and this is combinations. Add one function with another function. One equation with another equation. All right? It means you add both sides. Think of section 7.2. This is exactly what you did in section 7.2. The only difference here is you're going to be doing it with 3 equations instead of 2. But for this rule right here, you are doing it with only 2 equations at a time. So there's going to be one that kind of always stays the same. Okay, so the goal here is we're going to take this system of equations and put it into row echelon form. And the idea of row echelon form is it kind of always follows the same order. You want to get 0 here, 0 here, and then after we will get 0 here. So that's our plan of attack every single time we try to put something into row echelon form. Now we're going to do that by following the 3 rules earlier. Now, I like the order these are set up in because usually I find it easiest if there is a 1 in this location, a 1x. That's what I prefer. So if that's a possibility, I'll put it there. If it's not, I can work around it, but I try to get a 1 here, and because that 1 is there, I'm not going to switch anything. What I am going to do is I'm going to combine these 2 equations. All right? I'm going to add them together. So the top equation is going to stay the same. X minus 2y plus 3z equals 9. Now what I am going to do is I'm going to add these 2 together, and the reason I'm going to add those 2 together is because they add to 0. So that gets the 0 here that I wanted. Remember I said we're going to try to get 0 here first. negative 2y plus 3y, I add those up, that's plus y. And 3z plus nothing is going to be 3z. And at the end, 9 and negative 4, that adds up to 5. Okay, so that was our first step. All right, get 0 there. All right, the next spot is we want to get 0 here. All right, but obviously adding x and 2x isn't going to get me there. So what I'm going to do is I'm going to multiply this top equation, both sides, by negative 2. If I do that and then add it to the top, or I'm sorry, then I add it to the bottom, I will get everything that cancel out. So what I'm thinking in my head is, okay, this top equation is really negative 2x plus 4y minus 6z equals negative 18. These numbers I've written in green can now be added to this equation, and if I add them together, I get the 0 here that I want. All right, this is going to be 0. That's important. Next up, I've got 4y and negative 5y. Those are going to add to negative y. Good. I've got negative 6z and positive 5z. Those add up to negative z. And I've got negative 18 and 17. That adds up to negative 1. Good. So that's really the first two steps of row echelon form, because the first two steps of row echelon form, again, are getting 0 here and 0 here. The next one is to get 0 here. How are we going to do that? Well, again, it usually, so if I had to sum up what we just did, we used the top equation to get 0 here and 0 here. Well, if I'm going to sum up our next step, we're going to use the middle equation to get 0 here in the same exact manner. So what we want to do is we want to add the middle equation and the bottom equation, because if I add positive y and negative y, that's going to add to 0. So top equation is not going to change. X minus 2y plus 3z equals 9. In middle equation, in fact, I don't need to write this 0 here. Most people don't, because then you just write y plus 3z equals 5. And now here's where the addition comes in. I'm adding these two together. They add to 0. Usually when it's 0, I don't write anything, but I'll put it there this time. 3z and negative z, I'm going to add them. I get 2z. And 5 and negative 1, that is 4. This is essentially row echelon form, because this bottom equation I could solve and say z equals 2. So if you were to put this in a perfect row echelon form, you actually wouldn't write it as 2z equals 4. You would write z equals 2. And now we are in the same exact situation we were. And in fact, if you look at your notes that we started this page with, this is the row echelon form problem that we previously solved. We already have its solution on the first slide. I believe it was 1, negative 1, 2 we got as the solution, so we already solved. So I'm not going to waste our time back substituting again, but to get to the answer, you do the same back substitution. You would substitute in a 2 here and a 2 here and solve for y and so on. What I do want to do is a little bit of practice and using these same methods of solving. All right, so, okay, so again, I told you I like to have a 1 here. That's important. And I want to get a 0 here and a 0 here. And the way I'm going to do that is by using a multiple of the top equation. Now, the multiple of that top equation is I want to multiply the whole thing by negative 2, because if this is negative 2x, it's going to cancel out. So we'll try to save some work here. X minus 3y plus z. This top equation really doesn't change a whole lot. What is going to happen is I'm going to multiply it by 2 and add it to the middle. So that's going to get the 0 right here that I want. Negative 2 times negative 3 is positive 6, and I add it to negative 1. So I'm going to get positive 5y. And then I got negative 2 times z. Add it to negative 2z, I get negative 4z. One more time, negative 2 times 1 is negative 2. Add it with 2, and I get 0. So there's a lot going on there. Negative 2 times 1, and then I had to add it. All right, so that's our first part. We got 0 there. That's good. The next one is try to get 0 here. And the way we do it, go back to that top equation. Remember, you're going to use the top equation all the time. multiply everything by -1. So essentially, multiplying it by -1 is going to change all my signs if I want to mark it in there. So I've multiplied everything by -1, and now I'm going to combine. It's going to get the 0 here that we always want to get the row echelon form. We're going to get 5y. We are going to get -z and -3z, -4z, and overall you're going to get -1 plus -1, that is -2. Great, so our first step is really accomplished. We got the 0 here, we got 0 here. The next goal is to get 0 here. And the way we will do that is we use the middle equation, and I think, how could I get those two y's to cancel out? And if I multiplied everything in the middle by -1, I could add it to the bottom and get it to cancel out. So I'm hoping you're seeing a very similar pattern in terms of the places that are being canceled out, right? And because that's all really these linear equations are. There's a pattern where we are canceling out. Okay, so I'm thinking in my head I'm going to multiply this middle line, or in fact I've got it written over here. I'm multiplying this entire line by -1. Now I do that in my head and I get -5y, and then I add it to the bottom and I get the 0y that I want. Right? I do another multiplication, -1 times -4, that's positive 4z. I add it to the -4z, and this time I actually get zeros. This is starting to look a little different than the last problem. -1 times 0 is 0. So I've got, on the bottom, I have no more variables. So I have this statement, 0 equals -2, and we came across this in the last section, in the last video. We were able to draw a conclusion off of it. And the conclusion, because 0 equals -2, doesn't make sense, there is no solution to this linear system. All right, we're going to do one more example on a future video, and we'll try to keep it short.